Hello, AP Stats. This is the last video for the day, which is the scavenger hunt answers that you guys did for today. And I'm going to go over the answers to each and every single one of them. Make sure you guys are all okay with this for the big day tomorrow. This was your very first question on your open-ended. I mean, no, I'm sorry, not open, your scavenger hunt. And a lot of you guys were kind of confused as to how they worded this. So if you see like what's happening, like in this terms of context, like these dots indicate obviously the number of students. And for this particular student, let's say this student received about a score of 35 on the midterm. But after this little study session, the extra study sessions were offered after the midterm. After that, this particular student was able to achieve a score of somewhere around 70. So what does that mean for this particular student is that the score has practically almost doubled as after you do the study session. And it's pretty much true for all of these dots. You can see how they range from anywhere between 30 to 50, but your Y ranges anywhere between from like 70 to even like 85%. Whereas compared to all the scores on the right-hand side, their score is somewhere practically between 85 to 100. Then your score is also somewhere between 90 to 100. So in terms of a significant improvement as a result of the study session, it was really much more significantly impactful for these lower end caliber kids versus the higher end caliber kids because they already received a very high score to begin with. So which of the following statement correctly interprets the scatter plot? All students have shown a significant improvement. That is not true because just like the one I told you, the higher end caliber kids, they did not show any significant improvement. Rather, they showed any improvement at all. The extra study session were of no help. That is not true because it definitely helped these group of kids. The extra study session further, no, they actually helped some students, like I said. Between these two, D and E, the correct answer choice here is going to be D. Students who scored below 55, in other words, the students who scored actually, on the lower end caliber, showed considerable improvement. Those who scored between 55 and 80 showed minimal improvement, and those scored 80 almost showed no improvement. So in the middle, they score some sort of a minuscule like improvement here and there, but finally at the end, they show really practically no improvements there. So therefore, the answer for this is definitely D. Okay, E is saying minimal improvement for below 55, but that's not true. You show significant improvement for the lower end caliber kids. 24 was one of those things that was I don't have my R value, so what am I supposed to do kind of thing. But remember, even if you don't have an R value, you can still solve it. SY over SX, 1.7 over 3.4 times the R is always equal to your slope. Don't ever forget that, please. And this actually comes out to be 0.5 exactly. So I'm just going to write it like this. That's your slope. So by looking at that, you want to ask yourself, okay, we know that R goes between -1 to +1, lowest and highest. If I were to plug those values in, the slope can range from anywhere between a -0.5 to a +0.5. That's the highest and lowest it could possibly get to. Therefore, the answer to this has to contain a slope that's between those two values, and it can't go anything above that. So A, B, and C is out. 2, 1.7, 0.75. They're all beyond 0.5 for that reason. All right, so then what I'm going to do is I'm going to see those two and really pick one or the other by using the other information that they provided for me, which said that 8, 10 is an actual point that goes into this, this equation. So the correct answer is D, because if you plug 8 as X, you get Y value as 10. Number 28 or number 3 for this one, which of the following can we conclude from this equation? So for every year the car gets older, the selling price goes down by approximately 9.83%. Okay, first of all, this is indicated by the selling price in thousands of dollars. So your price actually decreases by 0.983. That's not true. A new car costs this much, which is $15,900. For every new year that gets older, the price drops by this much. No, the price drops by this. New car, nope. So it's E. So every year car gets older, the selling price drops by $983. All right, I'm not going to go over that too much in detail. Let's move on to number 4. Number 4, yes, this was tough. We are talking about a frost warning, applying water to trees and seeing how this frost impact the trees, and it just it causes considerable damage due to the frost. To estimate the proportion of trees that suffered more than 50% of the damage due to the frost, he took a random sample of 100 trees from his grove. What is the response variable in this experiment? Quite honestly, for this type of question, I do not know if it belongs in the category of chapter 3. I just saw the word response variable and I gave you this question to kind of do it. But let's just first talk about explanatory. Oh, this is my fault. Okay. Let's just first straight up talk about explanatory versus response. Explanatory is something that you're not changing. Response is something that actually is a result of what you get as you apply the changes onto the trees. So the explanatory variable could be the amount of water that you're applying to the trees, the amount of frost, and the response is the damage is being done to the trees, like, because due to the frost and how much damage, the severity of it. So we want to first look for those types of contexts when we're looking for the response variable. So the proportion of trees that suffered more than 50% damage due to frost, like I said, damage. We want to look for the amount of damage that was done to the trees. So that seems to be like a really good answer. So I'm going to leave A alone. The number of trees affected by the frost. Remember, we're trying to measure to estimate the proportion of the trees that suffered more than 50%. So the number of trees themselves, it's not really a response variable, rather the proportion of the damage that's done by the frost to the trees is what I want to measure. So it's not the number of trees sampled. This is the worst answer up there. It's just 100. So how does it help me with the response variable? That's just the number of survey size. For each sample tree, whether it was sprayed with water or not sprayed with water. So this actually is your explanatory variable. For each sample tree, whether it was sprayed with water or not sprayed with water, like if it was sprayed with water or if it wasn't, it just kind of imposes like a treatment. So if it imposes a treatment or not, so based on that, how does your response from that come about? Does it, how much frost comes from applying the water, how much damage that's done? So D is actually not the answer because it's not talking about the damage done to the trees. The correct answer here is E, because for this type of treatment-based experiments that we're doing for this context, and this is much more, now that I think about it, it belongs in the category of chapter 4 that we're going to learn later on, which is literally the next chapter. Every tree that's being imposed a treatment on this, whether it's being applied with water, so spray all his trees with water. The water was supposed to freeze and form a protective covering. So we are supposed to actually spray all the trees with water. So this is just imposing treatment, but it's still considered to be a part of what we call an explanatory variable. Like we're applying those changes. For each sample tree, you have two options, whether it's going to suffer more than 50% or it's going to suffer less than 50% or at the maximum 50%. Those are your only two options that the trees can result in. The proportion of trees that suffered more than 50% damage due to the frost, those are only the proportion that you're only considering if it's above 50%. Yes, this is what you want to measure to estimate the proportion of trees that suffered more than 50% damage due to the frost. They literally say that specifically, but that is just the measurement of the test. Like that's what you're trying to measure. But look at the question, what is the response variable? You're more focused on the response variable than actually running this test yourself. Like, yes, you're trying to measure the proportion of the trees that suffer more than 50% of the damage. So that is something that you're trying to measure. But the response variable in this context is whether or not these trees have shown a significant damage or less significant damage. That's the response to the frost. So E is the correct answer because it shows a response. It shows response to the treatments, to the explanatory variable that was imposed upon them, the water that was applied to them, and the amount of frost that was created from that. Okay. So yes, this is confusing number 4, but I hope that this is a good explanation. And I'm just going to move on. If you have any questions, just please come ask me tomorrow though. Can shoe size be predicted from height? Okay, so this gives me the standard deviation 8.7. So that is for your height. And the standard deviation shoe size is 2.3. So shoe size can be predicted. So that is your response based on the height of this experiment or of this survey. So explanatory variable, which is your X, response variable, which is your Y. So the height is going to be your X. So 8.7 is going to be down here because that's your standard deviation of X, and the standard deviation of Y would be at the top. I want to find out the R value, right? So we want to find out the R, the correlation coefficient. It turns out that the slope is 0.25. So what that means is that is equivalent to saying B times 2.3 over 8.7. That was the equation. And you do not want to forget this, by the way. I'm sorry, that should not be B. That should be R. So this is the equation that you guys want to use. I'm going to use the calculator now. All right, so I'm going to find out 0.25 times 8.7 divided by 2.3. So that should be the correct answer. Actually, now that I realize it, they actually gave it to you in this format. So the correct answer here should be just simply A. Yeah. So just multiply both sides by 8.7. So this just becomes 8.7 times 0.25. Divide this away to the other side. So you can see how this matches that answer exactly. And get R by itself. It's just a pre-algebra question from that point onwards. All right, next question. We have the model's predicted battery life for the tablet computer consisting of costing $480, which we're talking about this, having a residual of 1. So $480 for the cost means that the battery life will be about 11 for the actual. Okay. This is the actual data. So we're talking about the predicted though. The actual, which is at 11 hours, minus the predicted, which we don't know, gives me the residual of 1, because that's what this data is talking about. So it seems to me that the correct answer here should just be A. And let's move on. A correlation of 0.6 indicates that the percentage of variation of Y. Remember, if you see this word right away, you know that that's R squared. So if it's 0.6 for correlation, remember correlation just straight up means R. The percentage is 0.6 squared, which is 0.36. So about 36% of the variation in Y, blah, 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 blah. So then how many times the percentage indicated by the correlation of 0.3, R squared of that will be 0.09. So if you actually compare these two, it's actually 4 times the amount of R squared value. So comparing this to that, so the correct answer here should just be C. This question was actually quite simple. This is 0. That's really close to being 1. That's close to being between 0 to 1. So if you think about it, which one has the first, second, and third relationship are okay? So we want to find out the R value that's the strongest, which should be R3 at the higher end, and R2 should be the correlate. R2 should be the lowest one, R1 should be the middle, and R3 should be the highest. Am I missing something here? So what is the relationship with correlation associated? Oh, I'm sorry. This is my fault. This is supposed to be R is equal to -1. This is between -1, R, and then this is 0. So what that means is it actually gives me the highest value of R for R2. And then it should be R1 because that's somewhere between -1 to 0. And then the R3, which has a -1. Technically speaking, the strength of it is the strongest, but the value is the lowest. So that's D for 27. 21, which of the following can affect the values of the correlation of R? R is super resistant, so therefore it's really not going to be impacted by mostly anything other than multiplying by a negative number. I talked about this in the other previous 2 videos, so please take a look. If you multiply the values of the data by negative number, then it obviously changes the values of Y's, which can make the positive correlation to make into a negative correlation. Change in the measurement of units, change in the X's and Y's, adding the constants, all the above can affect the R value. Nope, none of them. It's quite honestly, none of them can impact it other than unless you see that R value is not going to change. R is super duper resistant. Number 12, medical research team tests for tumor reduction in a sample of patients using 3 different dosages. Okay, so it seems like the amount of tumor amount of dosage is going to be your explanatory variable, whereas tumor reduction is going to be your response as a result of those dosages being applied. So you have 1 explanatory variable, by the way. It's not A. there are three different levels of dosage, but doesn't mean that your explanatory variable, there's three different types of the explanatory variables. There's just one. The one explanatory variable is the dosages. There is one explanatory variable with three levels of response. The three levels of response, you might consider that to be kind of true, and you should, but technically speaking, you're actually applying the three different dosages in the first place that actually gives you three responses. So you want to say one explanatory variable with three separate levels of that. So tumor reduction is response. There are three levels of single, yes, so it should be D. So there should be one explanatory variable, but there are three levels of the dosages that you're applying to, so that should be D. Each explanatory level has an associated level of response. You don't know if they actually have some sort of relationship. If all those three dosages give you the same response, then it actually does not give you the associated level of response. We can never predict that from just by reading this. We need the data to actually prove E is going to be true. So E is insufficient information. This question here, we see a positive trend, it feels like. But in the beginning, look at all these dots in the beginning. It just seems like all over the place. Even the years, like around somewhere between 0 to 5, it seems like the salary for, what is this? The college faculties can vary very much. So which of the following most correctly interprets the overall scatter plot? The faculty member with the fewest years of service makes the lowest salary, and the faculty member with the most years of service makes the highest salary. Okay, first of all, the fewest years of salary right here, I feel like it could be this one. Well, that's technically it. And the highest salary makes it with the highest amount of years of service. You might make an argument for A, but I'm just going to leave A alone for now and make sure I go over through everything. Faculty member with more years of service than other has a higher salary than the other. This is clearly not true because compare this point here and here. This person had 40 years of service and this person only had about 10 years of service. Their salary is about the same. So more years, more salary. That is not true. There's a strong positive correlation with little deviation. First of all, this is not a strong positive correlation. I will not agree with that at all because I see so much different residuals for that. I would consider it moderate, if anything. There's no clear relationship between salary and years of service. No, there is technically a relationship. There is a positive correlation, but it's just not strong. While there's a positive correlation, there's a distinct deviation from the overall pattern for faculty with fewer than 10 years of service. Okay, so let's take a look at what E is talking about. And that's basically goes along with what I said from before. If there's a linear trend like that, and that could be the best line of fit, in the very beginning, we see so many different levels of salary for the beginners that it just doesn't follow the linear trend so well in the very beginning. So you want to point this portion out. Even though A makes sense, the faculty member with the fewest salary, okay, so the years of service, lowest salary, most years of service, highest salary. Yes, I see those 2 points loud and clear, but does that give you the most accurate measurement of the scatter plot? Like if you're describing the relationship, E gives you a much more insight into the scatter plot, understanding the fact that before there's a distinct deviation over the faculty with fewer than 10 years of service. Before 10 years of service, if you look at all those data points right there, something fishy is going on. It doesn't follow the trend well. You want to point that out in this scatter plot, saying that that's the insight of the scatter plot that you see, rather than pointing out the lowest and the highest, which is very rudimentary. E is much more in-depth answer. A is technically true, right? But E is better answer. All right, next question, number 4. Which of the following is a correct statement about the correlation? So correlation, again, it's R value. It measures how much you differ from the line to the dot. If the slope of the regression line is exactly 1, the correlation is exactly 1. That is not true because slope can be 2, 3, 4 for all I care. The slope, if the correlation is 0, the slope of the regression line is not undefined. It actually has to be 0 because remember, guys, the slope is this. R heavily influences the slope of the regression line. It's just that it also depends on the standard deviation of the Y's and X's as well. But if a correlation is 0, who cares about the standard deviation? 0 times anything is still 0. So the slope also has to be 0. Switching which variables called X and Y changes the sign of the correlation. That's not true. Remember how R is super resistant. Even if you switch the X and Y, it's not going to change the sign of the correlation from positive to negative. The only time that happens is when you actually multiply each value by a negative number. The correlation R is equal to the slope of the regression line when z-scores for the y variable are plotted against the z-scores for the x variable. So this right here, okay, what I'm going to explain to you like this is, if I actually have the slope as the z-scores for the y variable against the z-scores of the x variable, z-scores, guys, by definition, it's the x minus x bar over standard deviation. What they're saying is that our slope is simply going to be the z-score y over z-score x. Now, is that going to be true or not? Or the correlation is equal to the slope of the regression line when the z-scores for the y variable are plotted. So this is basically what they're saying. The z-scores of the y1, let's say, the first point on the z-scores, minus z-score of y2, minus z-score of x1, minus z-score of x2. I don't want to go too much in more of a mathematical definition behind it, but z-score always deals with the standard deviation, yes? So the y minus y1 minus the y mean over standard deviation of the y's, let's write it as sy, minus y2 minus y, let's say, mean over standard deviation of the y's here also. If you actually were to do this mathematically, what you will end up getting is that y1 minus y2 over sy. That's what you would get. Then you would divide this by obviously x1 minus x2 divided by sx, because you pretty much get the exact same thing. Okay, so the R correlation coefficient by definition wise, I'm just going to write that down for you guys just so that you can have it. So the correlation coefficient formula R is simply equal to the sum of all of those values, like of the x's and the means, x minus x mean, and the y minus y mean here, all over the square root of the standard deviation, basically xi minus x bar squared, and then summation of all the yi minus y bar squared. This is the standard deviation of all the residuals. That's what this is talking about. And then this is just the summation of all the x's and the y's. So if you actually take a look at how they formatted this, this basically means that I am dividing by this value where it's going to be x1 minus x2. You know what? I'm just going too much in detail about this, but if you actually look into E, changes in the measurement of units of the variables may change the correlation. Like I said, correlation is super resistant, so it's not going to change. I am not going to go too much in detail with the mathematics behind this. Just remember the next time for D, that's the correct answer, because correlation is always determined by when you actually plot the z-scores of the x's and the z-scores of the y's, whatever that line that they give you, the slope is straight up R, because even looking at the equation perspective, it matches with the description of what the R value is. So that's another rule that I want you to remember. Z-scores plotted x and y, R is the slope. I think that will be a better way for you guys to remember for next time. All right, moving on to the next question. For the least squares regression line, which of the following statements about the residuals is true? All right, so influential scores have large residuals. Okay, so for this particular question, influential scores have large residuals. Technically speaking, if I am asked to actually find out what the points are, let's say a residual plot where it's gonna look like this, and I'm gonna plot a point here A, and it's gonna change the line dramatically. That's an influential point, but it actually falls under the line, so it's not gonna have a high residual. It actually gonna have a residual of a 0. So this is actually not true. If a linear model is good, the number of positive residuals will be the same as the number of negative residuals. The number of positive residuals doesn't matter. If I have one really big, large residual plus 10, but I have 10 small residuals of negative ones each, the number of residuals don't have to match up. The magnitude, they have to match up. So the answer here should be C. When you sum all the residuals from the line to the dot, they should all balance each other out into being a 0. So the number of positive residuals doesn't matter. It's the magnitude of the residuals, the positive residuals, versus the magnitude of the negative residuals. They should add up to become 0. Correlation is 0, there will be distinct pattern in the residual plot. If it's no, I don't think there should be a distinct pattern. If it's 0, that means it's a line is a good fit. If a line is a good fit, you shouldn't see a pattern. You should see scatters. If a correlation is 1, there will not be a distinct pattern in the residual plot. There will be a distinct pattern because if the R is 1, that means all the dots fall under the LSRL. So there's basically no residuals. So you see a straight up line in the residual plot, which is pattern. Not a curved pattern per se, but there's a pattern. 4 pairs of data are used in determining that. Okay. What is the mean of the 4 values? We did a very similar question on one of the variance tests. So what we have to do is we just have to plug these values into our X's. Okay. So I'm just going to simply do that. I think the fastest way to do this is just to use the list here. So I'm just going to use list 3 as 32, 24, 29, and 27. And then list 4, I'm just going to say it's 3 times list 3 plus 4. And so it just gives me all the values, 100, 76, 91, 85. They ask you for what is the mean of the 4 values of the dependent variable. So they just ask you to find the mean. All right, so 100 plus 76 plus 91 plus 85, divide that by 4. The mean is 88 from that point onwards. All right, moving right along. Number 9, also, this is super simple. They give you a point, just plug it in here, please. So 7 times -2 is equal to a 4 plus b. You're looking for the y-intercept. -14 equals 4 plus b, 18 equals b. So y-intercept is b of 18. Your slope 7 has to stay the same. Next question. Which of the following would be revealed by the graph of the residuals versus the percent of students in poverty? So that stays the same as your X. And if I were to draw a line straight down like that for your best line of fit, what's going to happen to your residuals? So there's a negative relationship between the residuals and the percent. First of all, the residuals, it's going to show like this. So something like this would show up, where the residuals actually, they tend to get smaller each time. So I don't think this is a negative relationship. I don't think. The next one here is the sum of the residuals is less. No, the sum of the residuals is always equal to 0. The variation, the mean EOC scores is not the same across the percent of all poverty. So percent of students in poverty, 5, 10, 15, 20, 25. The variation in the mean. Okay, so the variation is these guys. So the variation in the beginning is very, very big, as you can see, and then it slowly starts to get much more compacted to the line. So it's not the same across the percent. So it should be E for this one. So they get smaller, basically, the variation. The spread, they get smaller vertically. Suppose the correlation is R equals 0.19. Guys, the answer is this. Look at all the changes that they're doing. They don't change anything because they are not multiplying by a negative number. As long as you don't see that, the R value doesn't change. It's one of those super duper resistant things. Which of the following statement is true about the correlation coefficient? A correlation coefficient and the slope of the regression line may have opposite sign. That is not true. They got to have the exact same signs. Correlation 1 indicates a perfect cause and effect. Never ever talk about cause and effect in terms of correlation. Correlation always talks about association, how good of those two have to do with each other in terms of relationship. They never say cause and effect for chapter 3. That for statistics, we never say that. Oh, this happens. If event A happens and event B happens, we don't ever want to make that type of conclusion in statistics. Correlation of 0.87 and negative 0.87 indicate the same degree of clustering around the regression line. For this one, we want to kind of put a little pause button on that because it does indicate the fact that they have a same level of close proximity of the points to the line. Correlation applies equally well to categorical. You don't want to apply this ever. Okay, it's always got to be measured in terms of numbers. Correlation of 0 shows little or no association. No, that's not true. It just simply means straight up no association whatsoever. So the correct answer here is C. They do indicate the same degree of clustering because the strength of it is the same. It's just that the direction is different. 27. Which of the following is a reasonable conclusion? It seems like this scatter plot is just whole randomness here. So if So there is basically no relationship. There's no positive, no negative relationship. So job performance cannot be predicted from caffeine intake. If you read A through D, it says low, then low. So like as one decreases, the other decreases. There's no relationship. It's all over the place. So there is no relationship. That's what you want to say. Which of the following is the best estimate for the correlation? So it seems to me, because the dot is all the way here to here, it seems like more of a negative trend, but it's a very weak negative trend. The only number correlation coefficient that associates with something that looks like that, it's negative and weak, it's negative 0.815. For those of you that's saying like, okay, what if this was like zero relationship? I strongly disagree with you because of this endpoint down here. That kind of, even though it's not considered an influential point, that last point actually makes the line to be more of a negative shape than anything. Which of the following statements about scatter plots and their associated regression line is false? Okay, so let's talk about this here. A scatter plot gives an immediate indication of the shape, linear or not, strength, and the direction, and the unusual features such as outliers of possible relation between the two variables. So we're talking about scatter plots and their associated regression line. Is false, it says. So scatter plot definitely do give you a form. There's the linear or not. You can kind of make that. Strength, you can also tell that. So it seems to me this is true for me here. Outliers are points whose residuals in absolute value are large when compared to those of other individuals. Yes, that's definitely true. Outliers is always measurement of residuals. Influential points are points whose removal will sharply change the regression line. That is what the definition of an influential is. It changes the y-intercept. It changes the slope. It changes the correlation coefficient. So that's definitely influential. High leverage points are those whose x values are far from the mean of the x values. That's literally the definition of high leverage points. The best fitting straight line, called the least squares regression, minimizes the sum of the residuals. Okay, first of all, it doesn't minimize the sum of the residuals. It actually just the sum of the residuals is equal to 0. That's the definition of what a regression line is. So this is actually the one that's false. You don't want to minimize the sum of the residuals. You just want to straight up make it into a 0 for 22. Okay. All right. Oh, that is the last question here. Okay. So I hope that this video helps in terms of your studying preparation. Just make sure that you guys get the correct answers, and I'll see you guys tomorrow.